Hi class. In this section, what I want to do is I want to talk about real briefly the fundamentals of probability. So how to compute some very simple and basic probabilities. Okay, so the first thing I want to do in two objectives in this section is I want to compute what are called theoretical probabilities, then I want to compute empirical probability. Okay, so in general probability, things that are probabilities are assigned values between 0 and 1, always as decimals. A lot of times you might hear them referred to as percentages. So when something happens 100% of the time, that's actually as a decimal form of 1. If something happens 50% of the time, that's 0.5. Okay, but so anyways, the closer the probability of a given event is to 1, the more likely it is to happen. Okay, and the closer the probability is to 0, the less likely it is to happen. You can never have negative probabilities, so there will always be between 0 and 1. Like you can't say, oh, the probability this happens is -5%. Doesn't make sense. So just some definitions. So in probability, an experiment is what we call any occurrence for which the outcome is uncertain. Okay, so unknown results. The other thing about it is that it's repeatable. The sample space of a probability experiment is the set of all possible outcomes for an experiment, and that's denoted by S. So the thing about that is we use S to represent the set of all possible outcomes. So like if you flip a coin, the set of all the sample space would be S is equal to heads or tails. An event denoted by E is any subset of the sample space, like flipping heads, E would equal H. And the sum of all theoretical probabilities of all possible outcomes is equal to 1, meaning when you flip a coin, you know the outcomes are heads or tails. Well, if you take the probability of heads plus the probability of tails, you add those together, you would get 1. So to compute theoretical probabilities, if an event E has what we call N and then in parentheses E likely outcomes, okay, so like if some event E has 5 outcomes, and the sample space for this experiment, all right, we denote NS equally has N equally likely outcomes, okay? The number, the theoretical probability of event E, which we denote as P subscript E, or P in parentheses E, all it is equal to. So the probability of any event is equal to the number of outcomes, right, in that event divided by the total number of possible outcomes. Okay, so like flipping heads. There's one way you can flip heads. When you flip a coin, there's 2 outcomes. So that probability is equal to 1/2. And let's work another one. Okay, so you can see more exactly what I'm talking about. So a die is rolled once. So whenever we roll a die, we're always going to have a 6-sided die. So let's find the probability first of A rolling the number 3 and then B rolling an even number. Okay, so the solution here. So first, the sample space is the list of all outcomes. So S is equal to, well, the list of all outcomes would be 1, 2, 3, 4, 5, and 6. There's 6 outcomes. All right, so the number of ways that you can roll E or roll 3, so there's only one way in which you could roll 3. So the number of ways it could happen is 1. So the probability that you roll a 3, it's the number of outcomes that result in a 3, which is just one way that could happen, divided by the total number of possible outcomes, so the number of elements in the sample space, so that would be 6. So the probability you roll a 6-sided die and it comes up as a 3 would be one way that could happen, divided by the 6 total outcomes. Rolling an even number, okay, well, that event consists of, well, an even number would be the numbers 2, 4, or 6. So the number of ways that can happen is 3 ways. So the probability that you roll an even number when you roll a die, number of outcomes that result in an even number, well, that's 3 outcomes, divided by the total number of possible outcomes, which is 6, so that probability is 1/2. All right, so suppose you are dealt one card from a standard 52 card deck. Okay, find the probability of being dealt the following: a king or a heart. Well, so just so we're clear, a standard deck of cards has 4 suits: hearts, diamonds, spades, and clubs. Okay, and each of those suits has exactly 13 cards in it. It has a 2, a 3, a 4, a 5, a 6, 7, 8, 9, or 10. Then it also has a jack, a queen, a king, and an ace. So that means if I want to find the probability to get a king, well, there's 4 kings. Okay, there's the king of hearts, diamonds, spades, and clubs. And a standard deck has 52 total cards. So the number of ways you can draw a king from a deck is 4. The total number of outcomes you can draw from a deck of cards are 52 different cards. So that's 4 out of 52, which reduces to 113. The probability to draw a heart. Well, as I said, there were 13 hearts in a deck of cards. So there's 13 ways you can draw a heart. The total number of possible outcomes is 52. So 13 divided by 52 would be 1 out of 4 ways that could happen. Okay. So let's talk about empirical probabilities now. So this applies to situations which we observe how frequently an event occurs. So computing empirical probability is very much the same. You just take the observed number of times E occurs and divide it by the total number of observed occurrences. So here's an example. Okay, so I've got this table here, okay, and it's talking about males and females, and it's listing if they were married, never married, divorced, or widowed. And I also have totaled row columns, all right, and total columns right here. All right, so if one person is randomly selected from this population described above, find the probability that the person is a female. All right, well, the probability of selecting a female is the number of observed females. Well, let's look. There's 124 observed females divided by the total number here, which is 242. Okay, now these are all in millions of people. Okay, so the probability of the number of females is 124 divided by 242. That's roughly 0.51. So notice just the number of ways it could happen divided by the total. And that's it.